Hey everyone, how's it going? Welcome back to Daily Stand-Up. So the in progress ticket I have is for Rust add endpoint to get engine data. And this is currently in progress, and I'm going to show you the code behind this and it working. So basically the what behind this is, well, essentially I'm adding an API endpoint to be able to retrieve the engine data that's going to be sent to the database that for basically the snapshot in time of when the engine exceeds a certain threshold of temperature. So for example, if the engine exceeds 200, or was it 200? Might have been 500. At 500 degrees Fahrenheit, it'll post the data off to the database. And I basically want a way to get all the data from the database and return it, via a REST endpoint. So I'm going to do that in Rust, and that's essentially what this ticket covers. So if we go ahead and go into my Rust project here. So I basically, on the previous video, I showed you code basically to create a sub-project within another Rust project. So I have this sub-project with this library file here that basically contains a lot of the methods that I'm going to be using to do this essentially. So let me, I followed a tutorial beforehand, so you'll see kind of some carryover for that, like basically just the hello world endpoints. And then the one I added specifically is right here. So I'm going to be calling this engine details endpoint, and it's basically going to get engine data. And what this is going to do, essentially, at least for right now, until we finish the ticket up, is going to be printing off all the records that it pulls from a MySQL database running locally, and print those out to the console. So if we go ahead and go to this method here that I added, so this is just a public method, and it basically has my connection info to my local MySQL database running. But then the thing I had to do something interesting I'll show you in a second. So I basically established a connection to MySQL and then run this query against this table here. So engine details table, which corresponds to this table right here. Let me just get the first 1,000. So basically this is essentially this is built off of that DTO object that's in my .NET solution that has all the engine details that gets passed up to my Rust microservice through RabbitMQ. So this is basically all that data, contained in this table. So I have two tables currently: engine details and user engines. For this example, I'm just going to be querying the engine details table. So that's where it's coming from, and once we establish that connection, we're going to execute the SQL, and then we're just going to print the rows out to the console. And then where this is actually going to be called from, you can see that this get endpoint, we establish the route, and then it's going to call that method. And then it's just going to return a OK status with this body. Where this gets a little weird is that I want since this project is contained in my existing Rust project that connects to RabbitMQ and consumes all that data, which is this main file right here. You can see that I'm going to have a couple things I have to get around. So I already have a running thread running for main that is actively processing my RabbitMQ queue. It's established a connection to that. So I can't, you can see here, I already have an active thread that's established and listening to RabbitMQ. So I can't spin this API off, on the same thread. I have to create a new thread to essentially create the REST API running, as well as keep the open connection to RabbitMQ established as well. So that was the interesting part. So the way I have it set up currently is I created this method in my sub project to go ahead and spawn off a new thread. And then I'm going to, I have a method called start server, and the server basically, let me see if I can get a, Let me see. I was trying. Oh, hopefully looking for like a quick documentation that I'll tell you. Let's see. The struct represents an HTTP server instance and is used to instantiate and configure servers. So we're making an HTTP server to serve our REST APIs. So this is kind of neat. So you can give it all like the routes essentially. So the one I added is this service here. So get engine details. And then I changed the port it's hosted on. So it's obviously it started off at port 8080. I made a port 8083 because I think I'm pretty sure if I remember, I think port 8081 is already taken. I guess I could do port 8082, but I just went with port 8083 because once I have all my services running, I might also have to change this. I don't know. This is what I'm gonna have to figure out once I have this running with all my .NET stuff and also RabbitMQ. I'll see. The port should be fine though, but I'll see. So I'm gonna go ahead and run this, and I'm gonna show you what's going on here. Let me just go into my project here. Cargo run. All right. So now once I've run it, again, if we go back to the main method in Rust here. So this is the main entry point into my Rust microservice. The first thing I'm going to be doing is now spinning up a new thread and starting the server to serve all my REST APIs. Sorry, I think my camera died like midway through or something happened to the connection. But anyway, so I'm going to go ahead and pull Postman up, and then we're going to see this running. So again, I have my Rust service running, and can I make this bigger? Yeah, let me just, okay, there we go, perfect. So this is the default get endpoint, so you can see it running, so it serves back hello world with a 200 code. So that's good. So now the one that we added is the one that we want to test. So I'm gonna go ahead and hit get, engine details. That's the endpoint we added. So if we did this correctly, you should see when I call this, the console spit out a bunch of data from the database. So printed engine data to console. So let's go ahead and go back into Rust. And you can see the engine data from the database. So it returns back all the rows which correspond to these rows here. So it has 3 rows of data for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So it sends back 3 rows. So that's super. That's awesome because this is exactly what I need to be able to query into my database to get all the engine data back that I need. And I wanted this to be the responsibility of the Rust service to do this because I want Rust to be responsible for all the engine data processing. I don't want .NET to do that because .NET, that's where the data originates from, but since Rust is actually performing like the logical operations on the data that gets served to it from RabbitMQ, I want Rust to do this. And again, it's neat because I've never built something like this in Rust. So just more for like the experience. But yeah, so it seems to work pretty well. Again, you can just like spam that endpoint, and it's just going to print back all the data. So very, very cool. The other thing is I have to now create a post method for actually, or no, do I? I was going to say that I might need to add a post method for the engine data, but that's not true because where I'm actually going to be posting the data to the database is probably going to be right. Let me find it in the code. The scrolling on this is crazy. It like skips like 8 lines. Greater than 200. I'm probably going to be posting the data right around here, and I'll explain the reason for that in a second. To do add connection to MySQL to post data. So So I'm just going to be posting the engine data up to the engine details table. The reason I want to do it here is because this is the point in the code where if we've said that we now have 200 instances of the engine overheating, so the engine's greater than 500 degrees Fahrenheit, then let's go ahead and take a snapshot of that engine and let's log it into the database. The database, I guess you could look at it as like it's going to be our running log of any anomalies in engine performance. So at this instance in time right here, we know that, again, depending on the RPMs, 4,000, 4,500 requests or rotations per minute directly equates to how many requests we're going to be sending per minute. So you can see how like 200 might sound like a lot. It might sound like we're going to be missing like a snapshot of data, but we're sending so many requests through the system that it's going to be, I think it should be pretty accurate. So that's just one instance. I don't know. I have another check for, so that's 200. And then I need to add it here as well, because this actually initiates the engine shutdown. So if the engine hasn't cooled, by this time yet, or if there's some just weird, like if there's still, basically if the engine isn't functioning still, then we're going to trigger a shutdown. And I probably will need to also add a connection to MySQL here, post data to MySQL as well right there. Those are just two things that I need to do with it, but I'm going to be adding more variables that I'm going to be checking for as well. But now this is going to be really nice because, again, I have two threads running, so I can get the engine data back that I need. And obviously I'm not going to be putting it back to the console. I still have a lot of work to do, so I'm either going to return it in a file, or I'm just going to return it as a JSON object. I haven't decided yet, though. The file might be kind of convenient for like analytics purposes, because this is mainly just as a diagnostics tool that I might connect back to the front end. Like, hey, when the engine stops or as it's running or whatever, go and get me the log of this engine, with these certain conditions. So Rust is going to be responsible for serving that data. So this is really how this is going to be used, but I'm excited to see this kind of come together, especially the ability in Rust to create a new thread and then host another server and then have them running at the same time is super cool. So I have to experiment a little with that. So again, this is like super prototype test code, and I have a ton of like stuff I need to clean up on it. But I'm just testing the core functionality, and it's working really, really well. So I'm excited about it. A couple of the other things I have to add to this. Again, I have to finish what I started today, and then I need to add the logging back to the logging queue based on those instances. So I have that RabbitMQ logging queue that's responsible, or I should say that's going to be responsible for all the logging of our system, and then it's going to create that single trace for all of our systems with an ID. So anyway, that's it. Again, more Rust content, and there's going to be a lot more coming on the channel. I should say I haven't done a lot of work on that one location feature that I've kind of been like talking about a little bit. That's coming. I just kind of got tied into this. So I'll probably finish this, and then because the location feature is a little bit bigger, more involved feature, so that's going to take a little bit more time. So I just need to spend like a few weekends and really kind of put some time into there. I also want to say that I posted on Sunday, I think, the first like research paper recommendation that I on my community post. I would expect that I'm going to post more of those. Probably I'm going to try to make that an every Sunday activity, because there's a lot of papers that are really, I think, beneficial for system design and just really just different topics in general that I find to be really interesting. I'm going to try to limit it to research papers. I might have a couple like Wikipedia articles every once in a while based on a little more obscure topics. But I think I'm going to stick to papers. So the last one I did was on the persistent data structures, which is kind of a cool topic. And I think the paper itself was from the 80s. And I have a couple books from, if you've ever looked at McGraw-Hill's computer science series, these are books that were published to like, I think 80, 81, but there's a whole series of them. And they're really cheap books, but they cover like, they cover really interesting topics in, probably more detail than you'd ever want to go into. But it's neat because, especially the distributed systems book that I'm kind of been this going through a little bit, it brings up issues that are still kind of being worked on today. Notably some issues around database locking and, how do you maintain consistency across databases? You can look up a term called eventual consistency that kind of deals with that, but it's really fascinating because it's like we're still kind of wrestling with the same issues. We're just kind of like putting a new face on them and just kind of creating technologies to help solve the problem. But it's almost like we haven't truly solved some of the problems that were talked about 40 years ago. So I don't know, it's kind of interesting, but I'll try to post more research content as I find it and reading it. So anyway, that's it for today's, and I'll see you on the next one.